Okay guys, so in this video we're going to talk a little bit about APIs and testing of APIs. So let's get into it. So something that I think that I want to cover in this video is basically the basics of endpoint versions and a little bit on how to, it's not going to be a dictionary to how to write every single possible thing that you could imagine when it comes to APIs, but I just want to give you an introduction to kind of the mindset that you should bring with you when you're making an API of some sort. So something that we need to kind of think about is that when we build an API, we need to remember something, and that is that we need to always think about the consumer of that API. Now, usually, if we're making like a single client to server type of application where we are the only consumer or API or SPA or whatever, is just being used by our own internal system. So we own all the code. It's not much of a problem because we can change an endpoint whenever we want because we're in control of the code that is going to consume that endpoint. As an example, if you're building a Vue or React or an Angular app or something like that, and you change the endpoint, then you can immediately go and fix that code so that both the front end and the server are reflections of each other, right? So they can communicate. But it's very easy to forget that if you have an API where this is not the case, where you might have other services, maybe you're working for a customer that has their own system, you're making some type of integration, or if you have another team in your company or something like that, this becomes a little bit of a problem. So what we call changing an API so that it breaks for somebody else is basically the term is breaking changes. So introducing a breaking change to a API is something that is very bad, because basically what it means is that whoever is using your API is now going to have their application broken if you just update and you send that out into production or wherever you're pushing it, right? So what we're going to do in order to mitigate this problem is to write some type of test. We need a test, basically, on our side, when we're the developers of the API, that makes sure that we are at the very least informed when a breaking change has happened. Now, I have here a small little server. It's just an Express server. And here is this very simple little server just for demo purposes. And all it has is a single user model where you have a name and an age and a function. And that's it. So the basics of this is that I would have something like this. I would have what we call an API spec, or like an integration test. I call it whatever you want. But basically the idea is that we simply spin up the server before everything else, and then when it's done, when the test is done, we close the server, and then we have these different tests that assert that the expected behavior of the API is actually what we have promised to the end consumer. Now, the first thing we're going to look at here is this test here, which I call a bit of a naive test. Now, the reason why this is a naive test, if you just look through it, so we have our user function that we're extracting from the user model here, and then we instantiate it, we send a GET request to our endpoint, we grab the data, and then we just expect that these two are equal. So what's the problem with this? Well, there's not necessarily much of a problem. It's even less of a problem when you're working in TypeScript or JavaScript or something like that. It is, though, a problem in a typed language. It could be a much bigger problem in a typed language. You see, what I'm doing here is basically that I have connected the implementation details of my server code into my test. But this is the wrong mindset, because this test that I'm writing should be a reflection of the code that is going to be on the client's side, the customer side. And the customer has no knowledge of this thing I call a user. They have no idea what this is. All they know is that if they call this endpoint, they're going to get back a JSON object. But this is not what my test is doing. My test is using my own model to verify itself that this model is the thing that is being returned. So if, let's say for the sake of argument, that I updated my model with something new and I said foo here, so I added a new field here to this test, and then I went and updated my model, my test would pass. But the promise that I have made to my customer has now been broken. This is a breaking change because now I have changed the response data without being informed that I did so. And this is something that you need to keep with you. This is even in a typed language, such as say Java or Scala or something like that, where you have the ability, in these languages you have a bit of power when it comes to formatters and things, ways of serializing data. So in these cases you could actually create a really big problem if you're just using the model directly, because in theory you could change the data representation, the actual type of the user, or the actual object, to be something else when it has been serialized or deserialized. You can actually write custom formatters and serializers that do this, which means that you are even more important that you don't use the actual model that you have in the code, but rather do something more along the lines of this, where, all right, I have an object that I expect in a certain shape, and then I do a get, and then I assert on that object. That's the thing that you're after. Because I hope this makes sense to you, because this, even though this is the same thing, that doesn't matter, because I want to be 100% sure that when I change this, that I never get to a point where I'm not informed that I just introduced a breaking change, because this test here should at no point ever break when I'm working on the user model, because if it has, then I know that I have broken something for a end consumer somewhere, or I could potentially have done so. So how do we kind of keep things in sync here? Because this can be a bit of a hassle to actually keep track of. Now, you don't have to go this far. I think this is great, like using the OpenAPI spec and using a definition file like a YAML file like this that actually specify. I can actually show you the actual thing here. So this is the Swagger editor, and it's this is absolutely amazing. If you're using, if you are defining an API, I highly recommend that you define it in this sort of manner, because it helps a lot. Because then this is basically your documentation. This is the documentation that your customer is going to use, and it's the same thing that you should use when you're implementing your tests, right? So here you can see here that I have defined, like in my user model, what it should look like. I have defined my endpoints here. We have a user's endpoint, there's a get, and there's a post, and all of this good stuff, right? So now I know that if I change anything here, if anything breaks here, then there is a mismatch between this Swagger file and my actual test, and then I have to have a way of handling that, because I can't just make a breaking change without either informing my customer or whoever is going to consume this that, hey, you're gonna need to update your code. Now, a way to do this I will show you as well, which I think is this should be I'm not saying standard practice, but it is very common to do this. One thing you may have noticed here is that if we have a post request here as an example, it doesn't have to be a post request. This is true for everything, but you see we kind of do the same thing here. We create a user, and then we expect that user, and then we just send the post request. Now the problem here is that we don't, if I change this model, because it might be the case that we wanted to add a last name or something to the user. Now the problem here is that if I do that, once again, I don't really have a way to be what we call backwards compatible. And backwards compatible basically means that you introduce a breaking change, but you still support the old way of doing something. And a way to mitigate that problem, because you don't really have that option here. You could say users-old or users-new. Like anything you do with this route, this URL, is a breaking change. So if we start thinking about versioning our endpoints, we actually get this fairly quickly. I'm not saying for free, but it's a very efficient way of solving this sort of problem. So here we have a less naive test where we do the same thing here. We have a payload where once again, like the mindset I want you to take away here is that you write the API test as if you were the consumer of the API. You assume nothing about the system. This is basically like this API is just a black box. You don't care. This is like your process should basically be this. You go here, you read this specification, and then you go and make the test based on this specification. You don't use the models. You don't do anything. You're basically just doing it as the consumer of this. And here we see that we've added something like API/version1/users. Now, what's nice about this is that if I go to my code here, like this is the actual implementation, if I have this endpoint without a version, it becomes very tricky for me to be backwards compatible, because if I change the behavior of this, it's almost impossible for me to know if I broke something for the end consumer. But if I have a version, then it's very simple for me to simply say, all right, I mean, I'm not saying you should do this, but you could copy paste this logic and add a version 2. And all of a sudden, all the tests that you wrote for version 1 are now still valid, and you can simply update your tests here, add a new version, and add those tests on as well. Which, I mean, I'm not suggesting that, I mean, ideally you shouldn't have to update versions all that often, but this is a way that works fairly well if you're in that situation where you actually need to make this sort of update. Now, lastly, I will give you just some of my own thoughts on this, and that is that in a perfect world, like as I said in this comment up here, if we want to be a bit advanced, the best way to do this is if we could connect our test to the actual Swagger file. So an example here would be that, well, just the mindset basically. I mean, you don't have to go this far because that gets a little bit advanced. That's why I didn't include it in this video, because it's about a bit out of scope here. But ideally, your test, the API test that you have written, should be a reflection that covers all of these different endpoints. And you see here where I have responses for the different response types. Like, this documentation is the thing that you're showing to your user or your end consumer. And this documentation should be the driving force behind the tests that you write. So all of these tests here should be geared towards to verify that these specifications that I've written down are actually correct. So if you could, and you can, since this is just a YAML file and you can make it in JSON as well, you could actually parse this information here, like the user model, directly into your test and basically just generate the models that we expect from this documentation. And that's a different video, but that is getting a bit advanced, because otherwise, I mean, it's still fine. It's just a little bit more work to make sure that whenever something breaks here, you need to remember to go here and update things. But hopefully this has given you kind of like a few ideas around how to write API tests and like some small tips. So the thing that I want you to take away from this is, number one, make sure that whenever you write a test that is designed to test your API, never ever assume anything. Like, don't use like models or stuff like that from your own code. Write it from the perspective of the consumer of that API, always. And then add versioning, like make sure that you always have a version for your API, because that way you can actually, you know, change and create breaking changes without breaking everything for everybody who's on version 1. And, you know, then you simply shuffle everybody over to version 2, and then hopefully in time they will also all update their code to version 2, and then when nobody's connecting to version 1 anymore, you can deprecate that and remove it. And then finally, use some type of like this, so like using an open API spec or else like a Swagger specification or something like that is immensely useful when you are defining an API. I hope you found this useful. Have a great day.